Okay, so we're starting chapter 3. As I mentioned, this chapter is called Properties of Geometric Properties. Okay. So the first 2 pages are just characteristics that you already know. Alright, so for example, how do you define a rectangle? It has parallel sides, and it has 90-degree angles. Okay, square, all 4 sides equal, and it has the same length, same slope. Okay, is a square a rectangle? Yes. Is a rectangle a square? No. Alright, so notice these characteristics belong to here too, but these characteristics don't belong here. Alright, so remember we you guys know it since grade school, right? Okay, so a square is a rectangle, but a rectangle is not a square. Okay, and then these are some other characteristics of parallelogram, rhombus, and a kite. So in grade school, how did you prove these? How did you prove these shapes? Yeah. Yeah. So in grade 5, Quinton, in grade Ethan, sorry. In grade 5, we proved these using rulers, actually measuring like 5.8 centimeters on every side and so forth. Now, in grade 9, grade 10, we talked about these before. When we talk about same length, all right? Instead of using a ruler, what do we use now in grade 10? Formula, right? The distance formula. What about slope? That they're parallel. We use the slope formula. And what about the 90-degree angle? What do we use to prove that? Ming-En? No, we don't use protractors anymore. No more protractor, no more rulers. Andy?
Like the
perpendicular slope, right? Negative reciprocal slope. So that's what we're gonna talk about today. This right here, circumcenter of a triangle. So actually, here I'll go back to that. Okay, let's recap these ones first. So remember median? There's 3 median in every triangle. Just like the one that I just showed you, I drew 3 medians to find the. Okay. Right bisector. Remember what right bisector is?
Yes.
What is it?
Wait, can you turn up your brightness?
Sure. There. Okay. Right bisector. What are right bisectors again? Gavin?
The point through the other side of the thing. I don't know.
At what angle?
Right.
At a right angle, right? Midpoint at a right angle. Good. What about altitude? What's altitude? Yep.
Like the height.
The height of the triangle. So from a vertice straight down to the opposite side at 90 degrees. All right. And then we just talked about this. When 3 median meet together, that point is called the centroid. Okay. So what about 3 right bisector? What do we call that? We call that the circumcenter. Okay. Circumcenter is when it's 3 right bisector. What about 3 altitude? Anyone know what we call that? Okay, so this one is called centroid. This one is circumcenter. 3 altitude is called Andy.
Orthocenter.
Orthocenter. And how did you know? Because it's on your sheet. On everybody's sheet. Right. Alright. Just to alright. Sorry, yes, I know I'm going back and forth with my package. I just want to show this one last one on the page. Circumcenter right here. The 3 right bisector of a triangle is called the circumcenter because if you draw a circle that goes around the vertice of that triangle, that's actually the center of the circle as well. That's how it came up with the name circumcenter. Okay? Circle, circumference, center. Okay, so I just thought this is an interesting fact to show. In a triangle, when you draw the three right bisector, it crosses at this point. So when you draw a circle around that triangle, that's also the center of the circle. Okay. So that's what I wanted. So this is just like a nice little refresher of the terms that we did before the March break. So let's do an example together. Okay, AY Jackson is located at 5-6. Daycare is located at -3-4. A senior's home is located at 1-2. The mayor is trying to build a fire department at the center of all three locations, which is the centroid of the triangle. Okay, so first let's draw it. Where is my pen? Here. Okay, so let's plot these points first. 5-6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So okay, so this is AY.
Wait, what page is that?
Page 2. Okay. The daycare is at -3-4. -3 and 4. That's the daycare. And then the senior home is at 1-2. Hi. Is it? I think so. 5 and 6. No, the numbers are just very messed up. Yeah, that's a 5. Okay, so when I draw, so let me draw my triangle first. Okay. I'm only doing one example today. Okay. Determine the midpoint and draw all three medians on the grid. So we'll do this. So the midpoint of DW is right here. The midpoint of SW is here. And the midpoint of DS is right here. Okay, remember I'm not drawing another triangle inside. I'm drawing three medians. So draw that median. Draw this median. Yeah. And then draw this median. Ah. Okay. And it looks like it's right here. What is the coordinate of my centroid? William?
1, 3.
Yeah, looks like it. Alright, so it looks like my centroid is at 1 and 3. Okay. Now, is drawing accurate? No. Even like this right here, even though I drew a very nice diagram, I can't really tell if it really is 1 and 3. So there is actually a formula you can use to find centroid. Okay, remember centroid is basically the center of gravity of all 3 points, like the middle of all 3 points. So when we did midpoint, what did we do for the formula? X1 plus X2 plus X3. Yeah. So if I have 3 for the Z, what do you think my formula should be? Yep. X1 plus X2 plus X3 divided by 3. Right. Okay. So with centroid is actually just this. And then y1 plus y2 plus y3 divided by 3. Okay. So 5 plus -3 plus 1 divided by 3. And then 4 6. Then 6 plus 4 plus negative 2 divided by 3. Okay. 6. So 2 plus 1, 3. 3 divided by 3, I get 1. 6 plus 4, 10. 10 minus 2 is 8. 8 over 3. So you see how my answer was a little off? Okay. So graphically, it looks like it's at 1 and 3, but mathematically, it's actually at 1 and 8 over 3. Okay. So this is nice and easy to find the excentroid. Is there a formula to find the circumcenter and orthocenter?
Probably, yeah.
No, unfortunately, centroid is the only one that has a formula, and it's nice and easy to do. The other ones,
The other ones are just pain.
yeah, the other ones are a pain.
It's pain. I'm telling you.
Yes, it is.
Is that pretty well?
Oh, and no, it's grade 10, and we're gonna be doing it right now. Alright. One thing I want to mention that on your last test, a lot of you gave me the answer like this. Alright. You need brackets around a point. So I was nice enough not to take off marks, but I could have easily taken off marks for not having the bracket. It's not a coordinate, it's not a point if I don't see those brackets. Okay? So, are you guys ready for pain? Too bad. Okay. So, example 2. Okay, this one right here. Circumcenter, the point of intersection of 3 right bisector of a triangle. So this one, I actually chose nicer numbers already. Okay, so a triangle has vertices 0, 0. Okay. So this is point O. 4 and 4. 4 and 4. That's A. And then 8 and 0. 1, 2, 3, 4. 8 and 0. 1, 2, 3, 4, 5, 6, 7. Yeah, okay, and that's B. Okay, draw the triangle first. Okay. Okay, so there's my triangle. Determine the equations of the 3 right bisector of the sides. Okay, do you guys remember how to do that? You had a whole test on it. Oh, okay. So let's do one. Let's just do one. Yes. Okay, so first off, to find the equation of the right bisector between O and A. Whoops. So between O and A, my first step is to find the midpoint. So midpoint of OA. The midpoint of OA. Remember the formula, x1 plus x2 divided by 2, y1 plus y2 divided by 2. Alright. So 0 plus 4 divided by 2. 0 plus 4 divided by 2. So you get 2, 2. 1, 2, and 2. Okay. Looks like the midpoint. Yep. Okay. What's next? Remind each other. How do I find the equation of the right bisector? I found the midpoint. What's my next step? Ethan? Slope of OA. Okay, so y2 minus y1 over x2 minus x1. Okay, so 4 minus 0 over 4 minus 0, I get 1. Okay, so the slope of this line is 1, but I don't want the slope of this line. What do I want the slope of?
Fill the slope of the right bisector.
The right bisector, so the negative reciprocal slope, the perpendicular slope. So negative reciprocal, so -1. Alright, so this is my right bisector right here. Okay, and so what is the equation? I have to put it in y equals mx plus b. Okay, a point on the right bisector line, a point on this blue line right here is my midpoint, 2, 2. Okay, so x is 2, y is 2. What is m? M is -1 because we just found the negative reciprocal slope. Okay. So when we solve it, b equals 4. Okay. I have m, I have b. So what's my equation of this blue line? Gavin?
Y equals -1x plus 4.
Yeah. Good. All right. Am I done part B of the question? Why not?
I got to divide by 100.
That's right. I have to do it for the other two sides too. So this one right here. All right. So this one right here, I'll just and then also this one right here. All right. Yes, it is. All right. So this one right here. Do you want me to just tell you the answer for this one, or you guys want to try it? Just tell you guys?
You know how to figure it out.
Yeah, it's the exact same thing. Yeah, so AB. So this right bisector here, AB is, the equation is y equal x minus 4, right? Yeah. All right. But let's do the this one. Let's do this one.
Oh. How does it even relate bisector?
All right. So this one right here, if so between O and B, the right bisector between O and B, I can find that my midpoint is at 4 and 0. But if I do all this properly, okay, mathematically, I'm going to get a slope of 1 over 0 because my line is vertical. It's going to give me a undefined slope. So what is the equation of this line though? William, x equals 4. That's right. So the equation of that line, because it's a vertical line, is just x equals 4. If you can tell it from the diagram, from your graph, you can just conclude that. You don't have to try to show every step here, right? Because it's just a vertical line. Okay. All right. And then, so if you take a look at the diagram right here, where is my circumcenter? Gavin?
0 and 4, 4 and 0. Oh.
Well, it matters. 4 and 0 is here. 0 and 4 is here.
Is there a lesson? Normally it's like y first and then x, right? What?
No, x before y. Always x before y.
Alright, so yeah.
Okay, so what is your circumcenter? Think again. 4 and 0. Right, so my circumcenter is at 4 and 0 at this point right here. Okay. Verify that this point satisfies all three equations. So, you know how Andy said this is a pain to solve? So if I just give you these two equations right here and I ask you where do they intersect, what would you do? How do we solve it? I have these two equations and I want to know where is their intersection point. Sydney? Or elimination or graphing. Chapter 1. Alright, so okay, so if I didn't show you guys in a nice little graph right here, and I say solve mathematically, you would have had to do substitution or elimination to figure out what is the intersection point. But because you have a third line that tells you what x equal, so what do I have to do? So just sub it in here. 4 minus 4, it is at 4 and 0. So to 1 second, let me finish this up. So for part D, certified that the point satisfied all three equations, I can sub it in the first one. My first equation was y equals negative x plus 4. I'm going to sub in 4 and 0. Right? So 0, 4, and so when you do this, you get 0 equals 0. So yes, that is correct. That means 4 and 0 is on this point. What about my second equation? Y equals x minus 4. Sub it into the equation. 4 minus 4. And I also get 0 equals 0. So yes, this point is on the second line as well. What about the third one, where my equation is just x equals 4? Sure. Yes. Yeah. Okay, and yeah, this is also satisfied. So if this point 4 and 0 is on all three lines, then it is an intersection point. And in fact, this is the circumcenter. The circumcenter. Okay. Okay. So this I actually toned it down for you guys already because one of the equation was x equals 0. X equals 4. Okay. Again, if not, then it will be the pain that Andy was saying, where you have to do two equations, two unknown, and solve it by substitution or elimination to solve for the intersection. Okay. So that is the lesson. Okay. So I just want you guys. So for the back page right here, I just want you guys to get familiar with like a refresher, drawing the right bisector and solving it graphically. So I want you guys to do that on this page. And then this right here, does this page look familiar? Yes. Yes. You guys got this before the break. All right. How many of you finished this page? Thank you, Jonathan. How many of you lost this page? Okay, so this is, well, if you lost it, here you go. It's in this new package now. So before the break, I gave this to you guys. You guys could have done it, but instead I'm just using it as a refresher. Everything that I did today is nothing new. You guys did this. It's just a continuation from chapter 2. It's pretty much what we've been doing. It's just a continuation. I don't think it's any harder, but it's just a lot of steps. Yeah, it's more annoying. Yeah. So the annoying part is like you're proving this and that by doing the same thing over and over again. That's all. Okay, so your homework, if you have not already done this, again, this you guys got before the break. Okay, so, oh, I forgot to put page numbers on these. That's what I forgot. Okay, so do this. So this page, circumcenter of a circle, and then this analytic geometry page. Okay, so do these next 3 pages for homework. Tomorrow we do quadrilaterals. Okay?